So first we're just going to talk about class stuff. The homework number 1 will be posted today. I have most of it ready. I just want to possibly add a question or two, and it will be up tonight on Canvas. It's due in 1 week on the 14th. At midnight. The homework is multiple choice and you have unlimited attempts. And aside from the due date, there's no time limit. So once you start the quiz, you don't have to finish it in a certain amount of time. And I think that's it. If you have any questions about homework, I'll be in office hour tomorrow. Or we can go over homework questions in class on Thursday. The last time we met, we started to talk about interval notation. And someone asked about being able to start homework and then finish it later. I'm not sure if there's a save option on Canvas. I'll check. I'll check that out. Let me even speak at it right now. Oh. Well, I forgot. I haven't finished making the homework. So if it's possible for me to put that as a setting, I will have a save for later, but I'm not sure if that's an option. So I'll check it out. Thanks for the question. So we're going to start off with how to graph an inequality. And then last time, I think we already talked about interval notation and just do a lot of examples. All right, so as a side note, especially in math, there's more than one way to solve a problem. And this is just one explanation of how you can draw these graphs. So what you could do is start with a number line. And the numbers go towards negative infinity on this side and over to positive infinity on the other. Then from the inequality, plot numbers on the number line. So we're going to say plot numbers. Use open circles for the strict inequalities. this one and this one. Use a closed circle for less than or equal to or greater than or equal to. So once you've got your open or closed circles, those marks are going to split up the number line into test intervals. I think this would be step 2. I think this is step 3. If you're taking notes. The next one would be to use test points between the plotted points. And when you test your point, if you get a true statement, you're going to shade over that test point. If it's false, do not shade over the test point. Okay. Again, false means do not shade. And I think that's it. First example is to graph the following set. It's the set that starts with X in R, and it's the double bar R, which stands for real numbers. So X in real numbers. And this means such that X is greater than or equal to 3. And then close the set. So we're going to start the graph first. And actually, after we do the graph, we are going to write the set in interval notation. Why don't you start a graph on the top? And looking at the set, x is a real number. That's our real number line. And x is greater than or equal to 3. So I want to put 3 on the number line and plot that value with a closed circle. So that plotted point splits up the number line, and we're going to test from -infinity to 3, and then from 3 to infinity, and then shade accordingly. And again, that number is going to split up our number line. And we're testing from -infinity over to 3. Go from 3 to +infinity. And you just need one test point from each side. So we're going to test 2, and then we're going to test maybe like 5. For values of x. Starting with x equal to 2, if we put it into the instructions from the set, which were having x greater than or equal to 3, you get 2 greater than or equal to 3, which is false. So for that first test interval, we're not going to shade over that side. Here, I picked x equal to 5 to test. Putting 5 greater than or equal to 3 is true. 5 is greater than 3. So we will shade over x equals 5. And like on that, over that whole section, from 3 to +infinity is our graph, and then is also going to be written in interval notation. So you start at 3, the smaller number, go to +infinity. You can include 3 since it has a solid dot, or since x can equal 3. So you put a square bracket to show that you have 3 in the set. And then you go over to +infinity, which can never be included. It's not really a number, so we're going to put a parenthesis around it. So this right here, this is the same, this means the same thing as the set that we started out with. It's the set that starts at 3, includes 3, and goes over to +infinity, or it's the set that contains all x values that are greater than or equal to 3. Next, we're going to graph. Let's do the graph of a set of X and R. So your set starts, it contains X in double bar. So what this is saying is X is a real number. X is in the real numbers, such that X is less than 1. And then we're going to close the set. And we're going to write this in interval notation after we draw the graph. Cool. So the graph goes from negative infinity to positive infinity. Check out your set and read the inequality part and graph the number 1 with an open circle. And we've split up the number line into 2 test intervals. One that goes from negative infinity to 1. The other goes from 1 over to infinity. There's that side. And the one that goes from 1 to infinity. This. Then we pick some test points. So let's try X equal to 0. And maybe X equals 2. Putting 0 into the statement from the set for the inequality in your set. So with 0, this is the problem, is I think that I changed the example to be less than X less than 1. And correct me if I'm wrong. There's a set of X and R such that X is less than 1. X less than 1 gives us 0 less than 1. 0 less than 1 is true. So you're going to shade over 0. till you get to 1, but don't include 1. So shade very close to it, but leave that circle open. And we're going to go ahead and check the other side. So I want to test x equals 2 to see if this is shaded or not shaded. If x equals 2, then is 2 less than 1? Nope, that's false. So we will not shade on the side that has x equal to 2. Which means this graph is done. We've shaded this side. You exclude 1 with that open circle. Don't shade that side. And what we need to do next is write that set in interval notation. So the set goes from the smaller value over to the larger one, which means we want to go from negative infinity to 1. And you never include negative or positive infinity. In this case, we don't include 1, so it also has a soft bracket or parenthesis. So this here is saying that we have a set that starts at negative infinity and ends at 1 and doesn't include 1. So before we leave this one, this was our graph. This is our set in interval notation. Okay, so we have the set of x in R such that your set starts, x is your variable, it's in the real numbers such that 1 is less than x, which is less than or equal to 4. Close the set. This time we're going to graph, and we're also going to do the same as before. Write the set in interval notation. Okay, so the graph goes from negative infinity to positive infinity, like this. Inequality has 1 and 4 on the graph. Part of this is where you have 1 less than x. So there's going to be an open circle for 1. An open circle over 1. And then the other part is having x less than or equal to 4. So there's a closed circle over 4. Okay, so I've plotted my points from my inequality, and those are going to split up the number line so that we're going to go from negative infinity to 1, test between 1 and 4, and then go from 4 to infinity. And again, between 1 and 4. So the set that starts at 1 doesn't include 1, goes over to 4, does not include 4. And then starting at 4, but not including 4, and over to infinity. So we need 3 test points. The first one we'll do is x equals 0. And then we'll try x equals 2. And then we'll do x equals 5. Okay, that first one is going to be x equal to 0. Put it into the inequality from the set. So 1 less than 0, less than or equal to 4. So this is an and statement where the whole statement needs to be true in order, like this piece and this piece need to be true for the whole thing to be true. And 1 less than 0 is false. Which makes the whole statement false, and you do not shade on that side where x is equal to 0. That part's blank. This part, we're testing x equals 2. So is 1 less than 2? And is 2 less than or equal to 4? Yes, true. And then here, 2 less than 4 is true. So this is true and this is true, which makes the whole thing true. So we will shade over x equals 2. Right now. Here and over to this one, back this way, over to this. And last one to test is x equals 5. 1 less than 5 less than or equal to 4 needs this piece true and this piece true in order for that statement to be true. So you need 1 less than 5, yes, that's true. And you need 5 less than or equal to 4. That's false. So do not shade over x equals 5. Cool. So that's my graph. We checked this part and that part and that part. We've shaded the area where we had a solution, and that's like a solution section between 1 and 4. So now we want to write that solution section, that set, in interval notation. So to make it clear, you would say x is in the set any number in the set that starts at 1 and does not include 1, goes over to 4 and does include 4 with a square bracket. So this kind of reminds me of something that I saw on the quiz, and it's not an issue, it's not a big issue, but it's just a matter of notation. So there's a symbol for, we're not going to use it in this class, but just for fun, I would like to show you this symbol. It looks like this, and this means exists in. Oh, actually, wait, this is math 1. I'm sorry. You guys don't have quizzes, so sorry if I scared you right there. My other class has quizzes, and a few people wrote something that was a little off, and I guess I'm just mentioning it to you guys over in a different class. So there's our set. You can say this if you want to, and this means exists in. For this symbol here, it means is an element of. So what happened in another class, and it's not that big of a deal, but a few people put something like this. So they put x equals this, but it kind of says x equals the set. But what we want to say is x is any number in that set. So the symbol, which is really, of course, you know, especially with typing, it's difficult to use sometimes, but we can write x exists in or is an element of the set that goes from 1 over to 4. This is a little bit extra. This is kind of past what I planned to do in class. I just wanted to show you for fun. Alrighty, we're gonna do another example. We're going to graph. The set that goes from -3 and is less than or equal to x, which is less than or equal to 0. So it's x. And see here, I could put like this. It says x exists in R, but it's not that big a deal to just write the word in. Such that, let's see, -3 is less than or equal to x, and that's less than or equal to 0. Close the set. Graph and write the set in interval notation. So you start out with your graph of a number line. We need to plot -3 and 0. And when we do that, we're checking out this piece here. -3 less than or equal to x means there's a solid circle over that number. Make my way over to 0 and do also look this way and look at x less than or equal to 0. Means we need a solid circle over 0. So I'm going to write up the test intervals. Those values break up the number line into an interval from -infinity to -3, go from -3 to 0, and go from 0 to infinity. Okay, there's that first one. Go up to 3, but not including 3. There's the next one. It's between -3 and 0. And the last one goes from 0 to infinity. So I need some test points. From that first interval, I'm going to try -4. Between here and here, let's try -1. And then above 0, I'm going to pick 2. So let's start here. -4 equal to x. You look at your set and put that value into the inequality with -3 less than or equal to -4 less than or equal to 0. So this is an and statement, which means most of them need to be true for the whole statement to be true. Is -3 less than -4 and is -4 less than 0. This part's okay. This part is false. Which makes the whole piece false. And we don't shade over -4. Okay, we're going to test x equals -1. With -3 less than or equal to -1 less than or equal to 0. And then just read through and make sure if it's each piece is true. If not, then it's going to be false. -3 less than or equal to -1. True. -1 less than or equal to 0. True. So this is true. So you will shoot over x equals -1. And last test. So that's a solution, and this piece here is part of the solution section. Part of your set of solutions. Now we're going to check this part right here, just in case. Okay, -3 less than or equal to 2, less than or equal to 0 is true right here. -3 is less than 2. But 2 less than 0 is false. And if it's an and statement like this, when one part is false, the whole thing is false. We're not going to shade the interval that has x equal to 2. Which means we're done with the graph. And then we want to write the set in interval notation. Okay, so it's a set, and how we write it is to start at -3, include -3 with a square bracket. It goes over to the other endpoint, which is 0, and you also include 0 with a square bracket. Okay, so my goal is to do two more examples, and this time the set is going to have the word or in it. So it's going to have two pieces in the interval notation. Okay, here we go. Of x and r. Such that x is less than 4, or x is greater than or equal to 7. And that's it, we close the set. We will check out this part and pull out 4 with an open circle. And then the other number that I really need is 7, and over 7 there's a closed circle. And we split up the number line into test intervals. The first one goes from -infinity to 4, then between 4 and 7, then from 7 and over. Okay, let's test x equals 3. And how about 6? Okay, so you read the inequality in the set, and we're going to put it into both parts. So 3 less than 4, or where are we? 3 greater than or equal to 7. So with 4, you just need one of the pieces true to make the statement true. So this one true or that one true. This one is true. 3 is less than 4. And even though 3 is not greater than or equal to 7, with or, again, you just need one of the parts to be true. So shade over x equals 3. Sign, just gonna shades. We're going to test x equal to 6. Okay, so we want to use the first part, 6 less than 4, or the other part, 6 greater than or equal to 7. That's false. 6 greater than or equal to 7 is also false. So here, if neither of them is true, then the statement is false. So that part is going to stay blank. We need to check this side here. Testing x equals 8. Cool. So it goes into both pieces. We're going to have 8 less than 4. is 8 greater than or equal to 7. This part is false, but the other part is true. Or you just need one side or the other side true. Since that piece is true, the statement is true. So we will shade over 8. And up to 7 and over to. That's the graph. When we get to interval notation, we need to put this set with that set. We're saying you're in this side or you're in that side. And we'll use the union symbol. So you start at the smallest value. We're going to go over to 4 and not include 4. Then union with the set that starts at 7 and does include 7. Goes over to positive infinity. Just remember, that's the union. Okay, one more, and that's good for today. So we're going to do a graph or a set. Okay, so it's a set of X and R. So X is in the real numbers such that X is less than or equal to 8. Or X is greater than 10. So start the number line. And place 8 on there with a solid circle. And we're going to go over to 10, which has an open circle. So we're testing from negative infinity to 8. 8 to 10. And then from 10 over. So we're picking test points. Let's try 7 and 9 and 12. Okay, 7 less than or equal to 8, or 7 greater than 10. That part is true. 7 is less than 8. And 7 is not greater than 10, but with or, you just need one of those parts. So this is a true statement. Which means we're shading over x equals 7. And then for this part, we're going to test 9. Okay. So, in your set, is 9 less than or equal to 8? Is 9 greater than 10? First one's false. 9 is not less than or equal to 8. Also, the next one is false. 9 is not greater than 10. So if neither of the statements are true, then this is going to be a false statement. So do not shade over x equals 9. Okay, we're almost done. We decided to test this piece up here. And for that section from 10 to infinity, I'm going to pick x equals 12. Okay. 12 less than or equal to 8. Is 12 greater than 10? First part is false. 12 is not less than or equal to 8. The other part is true. With an or statement, that makes this a true statement. Okay. And just like before, if we want to put this set, if you're in this set or you're in that set, we're going to use the union symbol, starting from the smallest value. Let's see, we're doing interval notation. Okay, so negative infinity over to 8 and include 8. It's difficult to write. Square bracket. Okay, union with the set. It starts at 10 and does not include 10. It goes over to infinity. So it's in that set or it's in that set. Okay, we're gonna leave a little bit early today, and oops, that should be the end of interval notation. But if you have any questions on Thursday, we can do some more examples. Otherwise, we're going to move on to a new topic. Okay, so we're done recording. I'll get this meeting posted tonight. And yeah, thank you. Thanks, everybody. Have a good day. But yeah, if you have questions, feel free to stay. Thank you.